All right, let me see. I guess y'all ready to start?
Yep, I'm ready.
I'm ready.
All right, yeah, y'all can see my screen, right?
Yeah.
Yeah,
All right.
I don't see us on your screen, but
Oh yeah, I got y'all on my top left.
all right, yeah.
All right. So this is our steam engine presentation for our thermal project, all by Ian, Jacob, and me. So what is a steam engine? A steam engine uses the energy saved in high pressure steam to turn heat energy into mechanical work. And it is based off the Rankine cycle and follows the laws of thermodynamics, especially the first and second laws. The first law basically means the total energy in a closed system remains constant. And the second law, it states that natural processes tend towards greater disorder. And the engine has a boiler that makes steam, a piston that turns the pressure of the steam into motion, usually back and forth, but it can also go up and down, and valves and other parts that control the cycle. This way, heat is constantly turned into mechanical energy. The temperature difference between the boiler and the condenser has a big effect on how well the steam engine works. And some brief history about steam engines. The removal of water from underground was one of the most important problems in the industry in the 1700s. The water from the mines was pumped out with steam. This might not seem to have anything to do with the current power plants that use steam today, but one of the main ideas behind the development of steam-based power is that water vapor condensation can make a vacuum. Although James Watt produced the idea of a separate condenser, which became pretty popular, today's continuous flow stream turbines do not use Cycilic processes, but they do use separate condensers that work at sub-atmospheric pressure, which is like the ideas given here. And some key components of a steam engine are the boiler, piston, valves, condenser, steam cylinder, and the crankshaft. The heat comes from the boiler, fuel is burned to turn water into steam. Most of the time, the steam that is made is hot and under a lot of pressure. The boiler must be strong enough to handle the pressure the steam creates. The piston is a part inside the steam tank that can move. The cylinder swells when steam enters it, which makes the piston move, usually back and forth. The valves decide how much steam goes into and out of the cylinder. The time of when the valves open and particularly important for how well the steam engine works. The condenser cools the waste steam and turns it back into water. In some steam engines, especially bigger and more efficient ones, this lowers the pressure inside the cylinder and helps keep the steam flowing, which makes the engine work better. The steam cylinder is the main part where the pressure of the steam is changed into mechanical power. Steam is steam is let into the cylinder and the pressure of it moves the piston. Pressure is then turned into mechanical energy as the piston goes up and down or back and forth. The crankshaft changes the piston's motion from moving back and forth to turning, which powers machines or makes electricity. This action turning is what the steam engine does.
And so for the key components of our actual steam engine that we designed, we have the base, the cylinder cap, the flywheel support, the piston push rod, the piston and valve housing, and the valve push rod. And they're all pointed out here. And so for the TV diagram of this, like this whole process of a steam engine, in processes 1 through 2, that's an isobaric heat addition. Water is heated in the boiler at a steady pressure. As it turns into steam, the temperature and specific volume both rise. In processes 2 to 3, that's an adiabatic expansion. And with constant entropy, steam expands in the cylinder, lowering both temperature and pressure as it pushes the piston. In processes 3 through 4, isobaric heat rejection, and steam condenses in the condenser. At low pressure, the temperature drops, but the specific volume stays about the same. In processes 4 back to process 1, that's an adiabatic compression, and the pump squeezes the flowing water, making the pressure arise, while the temperature stays the same. And this is kind of like a step by step of like how we did the construction of our prototype. And this is the completed version of the steam engine, and this is all the parts where, and this is kind of how we had it printed out. And then this is when we got it. This is when we first started sanding everything down. This is whenever we started putting everything together, and this is everything we had together after we had sanded everything down and had connected all of our different parts. And this, like right here, is tape to make sure everything stayed together. And this is a video of us testing our project.
So we had a few construction issues when during the construction of our project. Our most prominent issue was the incorrect tolerances that we had, mainly the valve and the valve housing, and then the piston and the piston housing. These components we had to spend a considerable amount of time on to sand down and get them to fit together. And we also had to lubricate these parts to get them to actually be able to move freely when we put air through the system. And then we also had some testing issues. A few of our parts did not stay connected to each other when we added air to the system. And so for this, we had to basically just tape it together to get it to stick, and then allow the steam engine to run properly when air was put through the system. And here you can see our team contributions that we had. I myself aided in the construction of the engine, and then gave us a space to where we could work on it and test it. Ian also aided in the construction, and then he is the one that is responsible for creating the PowerPoint. And then Matthew did a research on all the literature and also put our report together. For future reference, we would like to be a little bit more involved in the printing process. That way we can make sure our tolerances are correct and that we have a much more stable product upon completion. And then to close out, our steam engine did work. However, we had a few key challenges that we had to solve, and one of those being tolerance inconsistencies. And as you can see, we had to sand a lot to get it to work. And then our hinges, we also had to tape around those to get those to work. And so that's all. If there's anything else, please let us know.